Now we're going to put together the concepts of multiplicity and end behavior, along with the x-intercepts and y-intercepts, to graph a polynomial function. Okay, so here we have an example, p of x equals x plus 1 squared times x minus 2. Now before we start graphing it, we have to find all the relevant information, which means we need to find the x-intercepts, which are the zeros, along with their multiplicities. We need to find the end behavior, and we need to find the y-intercept. So let's discuss each of these. Well, the end behavior, remember to find that, you look at the leading term, which is the highest power of x appearing in the expression if you multiplied everything out. So here we have an x plus 1 squared, which means in this expression, if we multiplied it out, the highest power would be x squared. And then when we multiplied these two terms, we would have an x squared from here multiplied by the x here. So the highest power of x that would appear is x cubed. And that means that the end behavior looks like x cubed because it's an odd power. So it falls to the left and rises to the right. And so now we can start to draw the picture. We can start to draw it coming up like this because it falls to the left. And then it rises to the right, so we can draw it coming up like that. Okay. Now we need to find the x-intercepts and their multiplicities. So the x-intercepts where you set p of x equal to 0. And we see that it's already factored. So the x-intercepts are at -1 coming from this term and 2 coming from this term. So those are the entries in this chart. And now we also need the multiplicities of the zeros. So we go back. -1 corresponds to x plus 1. And the power here is 2. So this is the multiplicity of -1. For our other 0, 2, that corresponds to x minus 2. And this has multiplicity 1. And finally, to find the y-intercept, we plug in 0 to the function. And if you plug in 0 for x, you would get 1 here times -2. So in total, you'd get -2. Okay. So now, how do we figure out how to fill in the middle of this graph here? We know that the function has to pass through the x and y intercepts, but we don't know how it's going to do that. And the way you figure that out is you use these multiplicities. So if you have an even multiplicity, like 2 for example, then when the function reaches that value, when it reaches the 0, so in other words, as our function comes up and it's about to hit -1, if we want to know what it does, we look at the multiplicity, and an even multiplicity means that the graph bounces off the x-axis. And what I mean by bounces off is this graph, this line, could either cross over and go to the other side, in this case go above the x-axis, or it could bounce off and remain below the x-axis. And because the multiplicity is even, we know that that's what it does. It actually bounces off here and starts going down instead of crossing through and going up. And we can see that makes sense because we know that our y-intercept is down here, so the function must have stayed down here. So we can tell that this interpretation of the multiplicity also agrees with where the y-intercept is. So now we can keep drawing the function. It hits the y-intercept. It must turn around to get to this next x-intercept, right? Because we know it goes through here. And now again, to figure out what it does when it gets to here, we look at the multiplicity. This time, the multiplicity is odd. And if the multiplicity is odd, that means the graph crosses over the x-axis. So here, at -1, it bounced off and remained below. But now, at 2, because the multiplicity is odd, the graph will cross over and continue up, now above the x-axis. And we can see that that agrees with our predicted end behavior of the graph, because we knew the end behavior was that it rose to the right. So that's how you graph a polynomial based on the end behavior, the zeros and their multiplicities, and the y-intercept. Let's do another example. Here we have q of x is x to the fourth minus 4x squared. Now, we can find the end behavior right away. We just look at the leading term, which is x to the fourth. And since 4 is even, we can tell that it must rise to the right and to the left. Now we need to find the x and y intercepts and the multiplicities of the x-intercepts. So we have to factor the function a little bit. We can factor out an x squared from everything, and now we can factor this term x squared minus 4 as x minus 2 times x plus 2. And this lets us see our x-intercepts very easily. Our x-intercepts are at 0, 2, and negative 2, as we can see in this chart. And our multiplicities we can figure out by looking at the exponents that appear here. So 0 has a multiplicity of 2 because it comes from this x term. 2 has a multiplicity of 1 since it comes from this x minus 2 term. And negative 2 also has a multiplicity of 1. Okay. Finally, we need to find the y-intercept by plugging in x equals 0. And it's easiest to plug it in up here. We can easily see that when you plug in 0, you get 0. Okay, so now we want to finish graphing the function using the multiplicities. So we'll start on the left, we'll come down, and we hit the first x-intercept, which is at negative 2. Negative 2 has an odd multiplicity, so the graph crosses over the x-axis. That means that it could bounce off. If it bounced off, it would stay up here. But instead, because the multiplicity is odd, it crosses over, which means it goes from the top to the bottom. It goes from above the x-axis to below the x-axis. Now, the next thing we know is that the function's got to turn around and hit this next x-intercept, which is 0. And when it hits here, we need to look at the multiplicities to determine what it does. So 0 has a multiplicity of 2, which is even. So it bounces off the x-axis here, so it remains below the x-axis. And now finally, we know it's got to turn around and hit this final x-intercept, which is at 2. This has an odd multiplicity, so it crosses over and goes from below the x-axis to above it. And we can see that agrees with the end behavior because now it continues up. And there's our graph.